My dear loving students, today I want to discuss a very important and interesting topics of mathematics. This is known as binomial theorem. As I hope you have studied from earlier classes the expansion of a plus b whole square, a minus b whole square, a plus b whole cube, a minus b whole cube. But if you have to ask, find the numerical value of 85 whole to the power 5 or 101 to the power 4. So it is very difficult to calculate the value of 101 to the power 4 or 5. So if we split in term of binomial 100 plus 1 to the power 4, 9500 minus 5 to the power 4, then it will be easy. So to overcome these difficulties, here the binomial theorem is introduced. As you know, the Newton was given first this theorem, and the application of this theorem is very, very interesting. Try to understand it. If here we see x plus a to the power 0, of course the value of x plus a to the power 0 is 1. X plus a to the power 1. It is x plus a whole square. It is x square twice xa plus a square. X plus a whole cube. It is x cube plus 3x square a plus 3ax square plus x cube and so on. So what do you observe? If you write index of the binomial in a column and also write the coefficient of the variable also in a column, or you say row, then what do you observe? Index of the binomial is 0. Then entry is 1. Index of the binomial is 1. Then entry of the coefficient is 1 and 1. Index of the binomial is 2. Then the entry of the coefficient is 1, 2, 1. Index of the binomial is 3. Then entry is 1, 3, 3, 1. What do we observe? We observe a certain pattern. What pattern? You see, here, when the index is 0, then entry of the row is 1. Index is 1, entry of the row is 1 and 1. If you add this 1 and 1, join, you will get 2. What is this 2? Entry of the binomial when index is 2 and the coefficient of the second term. Coefficient of the second term. Now by adding coefficient of first term and coefficient of second term, we get 3. Coefficient of second term and coefficient of last term of the expansion of the binomial when index is 2, adding 3. And now we will close it by 1, 1. So what do you observe? This is the coefficient of the expansion of the binomial when the index is 3. And we observe that it forms a Pascal triangle. So by taking help of Pascal triangles, without knowing the binomial of the expansion of higher power, we can also write the coefficient. One interesting thing is that in the Pascal triangle, for index 0, the entry of row is 1, that is 0, C0. C stands for selection. Now for index 1, the entries of row are 1. 1 can be written as 1C0. And this one can be written as 1C1. If the entry is 3, index is 3, then entry is what? 3C0. 3C0 is 1. 3C1. When entry is entry of the row 3, that is 3C1, and that is 3C2, and 1, that is 3C3. So if in this way, if the index of the binomial is 4, 1, 4C0, 4C1, 4C2, 6, 4C3, 4, and 4C4, 1. So without knowing without expanding the binomial with respect to the power n, we can write the expansion of the binomial for any positive integer by following this rule. And this triangle is known as Pascal triangles. Here we have written the coefficient by using countings. We have written the coefficient of Pascal triangles by using countings. So my dear students, in this way we can expand the binomial with index n. And also we observe that here you see in the expansion of the binomial, the coefficient of equidistant term are also equal. Coefficient of first term is 1 from beginning, and from end 1. From beginning it is 2, and from end it is 2. Here from beginning it is 1, from end it is 1. Second term coefficient from beginning it is 3, and second term coefficient from last is 3. In this way, so many interesting property we will discuss in next video. I will discuss also how we will solve the problem of divisibility by using binomial theorem, inequality by using binomial theorem, and you will also learn about the coefficient of middle term, independent term. In this way, in next video, I will discuss in depth all the things. I hope you have understood my suggestion, my points, and by taking care of this suggestion and points, you will learn mathematics. You will go through this chapter in depth, and by making notes, taking regular class, I hope you would be in a position that you will solve not only the problem of class 11, but also the problem of competition. Thank you very much.